Hello pre-calc, and here we go with 7.4, solving trig equations. In order to solve them, we have to understand how the principal values work, which is basically how the calculator decides which quadrant to draw its answers from. So we have been working with the arc cosine, and here's the definition. That has not changed, but just to kind of go over it again, remember, the argument to an arc cosine is a ratio, and the answer is going to be a collection of angles, basically, when you evaluate it. And so where do we get those values from? Well, if the ratio is positive, then you draw your answer from the first quadrant. For instance, I'm just going to do it as an inverse cosine. If I have the inverse cosine of 1/2, my answer would be in the first quadrant. That goes with a 60-degree or pi/3 angle. If I had an inverse cosine of -1/2, then I would draw my initial value from the second quadrant where cosine is negative, and that would be 2pi/3. And again, if we did it as an arc cosine, you'd have plus or minus the value plus 2πn. All right, so that's what we've been doing. And the plus or minus is what then picks up the other place where cosine is positive or negative, because it just works very nicely that way. Unfortunately, sine and tangent do not work that way. So sine, or arc cosine, a little bit different, because over here we have the mapping. I drew a little diagram. Sine is positive in both the first and the second quadrant. So the calculator, if it's a positive ratio for everyone, they draw from the first quadrant. But for a negative ratio, it's going to draw the answers from not the fourth quadrant, but the pre-first quadrant. So it's drawing it from -90 to 90. For instance, if I had arc sine, I don't want to do the whole arc sine routine. Let me just do an inverse, because that's usually what the part you're evaluating. If I have an inverse sine of a +1/2, my answer would be 30 degrees or pi/6. If it's the inverse sine of a -1/2, I'm now going to draw my answer from the pre-first quadrant, which is basically, remember, a negative just sends you in the opposite direction, so my answer is going to be a -pi/6. In some ways, the answer is kind of easy, because it's whatever was in the first quadrant, just put a negative in front of it, because you're going in the opposite direction. However, there are two quadrants where sine is positive and where sine is negative. To get that second value, that is, I'm trying to look over here, where this part comes in. You have to use the supplement, whether in your radians or degrees. So to get over to here, I have to do, so if I was doing sine of 1/2, we know it's 30 degrees, and then it's going to be 180 minus 30 degrees, the supplement, or 150. So that's, you can't just do the plus or minus like you do with cosine. All right. Lastly, we have tangent. Now tangent, remember, only has a period of pi. That makes this a little bit easy, and tangent works like sine in that it's going to draw its principal values for positive from the first quadrant, and if it's negative, from the pre-first quadrant, from -90 to 90 is where it's drawing it. And again, you can see this if you enter something on your calculator. That's where the calculator can only give you one value. That's where it's drawing it from. So let's try a few of these, because we're going to be doing some examples. Some will be with calculator, some will be without calculator. All right, so let me get my calculator in, I'm in radian mode. That's good. Okay, find the general solution for arc sine -0.6. So the first thing I'm going to do is just go to my calculator and enter in, well, you know what, let me write down the definition. What does this mean? This means my inverse sine of negative 0.6 plus 2 pi n. And it also means, because notice I can't just put a plus or minus, but I do have two answers, it will be pi minus the inverse sine, negative 0.6. All right, so now let's go to our calculadora, and I go second sine negative 0.6. That gives me a negative 0.644 plus 2 pi n. And the supplement of that is going to be pi minus that value. So I just go, I'm going to use my actual pi key. And notice that minus the negative puts me in the third quadrant. Okay, so pi minus second answer, and that is going to give me 3.785 plus 2 pi n. That would be my general solution for the inverse, or for the arcsine. Now, if I'm doing a tangent, I have x equals, it's a positive ratio. And so all I have to do is, well, let's write it out. So this is going to equal my inverse tan of 4 plus pi n. So I just go to my calculator because it's going to understand where to draw the principal value. And we will be doing these without the calculator in a second too. And that gives me 1.326 plus pi n. Because realize, this was a positive ratio, right? So somewhere up here, when I add pi, because tangent's positive here and here in sort of diagonal quadrants, that plus pi n already brings in my other value. And then we come back to our lovely inverse or arc cosine. So this is nice because when you do the arc cosine, again, what does that mean? That means I'm going to go plus or minus the inverse cosine plus 2 pi n, and then I have to evaluate that. So second cosine of 1/4 is plus or minus 1.318 plus 2 pi n. All right, so that's using the calculator and coming up with your general solution. So with cosine, it's really nice the way it falls. You can just put a plus or minus. Tangent, it's just one value because it's only plus pi n. Sine, you have to enter in the original and then you take the supplement to get to the second value. Now, when we're solving without a calculator, this is how this would work. So I'm first going to subtract. I'm going to kind of do this all at once because I don't have a lot of space here. I'm going to subtract my rad 2 and then divide by that 2. Okay, so now we're going to take the arc cosine of both sides and use our definition. All right, so in the interest of space, I'm just going to go straight to, this is going to be the inverse of negative rad 2 over 2 plus, I guess I'm doing it in radians, and then pi minus the inverse, negative rad 2 over 2 plus 2 pi n. All right, so we have to evaluate that. Since it is negative, and this goes with a 45-degree angle, because rad 2 over 2 is your rationalized form of 1 over rad 2, my answers are going to be, so negative rad 2 over 2, that's going to, because it's negative, I'm going to pull my answer from the pre-first quadrant. That's going to be a negative pi over 4 plus 2 pi n. And then the supplement, pi minus a negative pi over 4 is like pi, that turns into pi plus pi over 4, which is 5 pi over 4. And again, if you map this out, so where are my answers? My answer's down here, and my answer's down here, because these are the two places where sine is negative. All right, let's do a tangent over here. So I'm going to divide both sides by -3. Now this is again your rationalized form of 1 over rad 3. That's kind of why I don't like the whole rationalization thing. And so we are going to be taking the inverse tan of negative, I guess I have to slip a negative in there, and then plus just pi n. So when we evaluate that, and again, if you don't know your trig right off, that's no big deal. You can just draw a triangle. Again, we're going to draw the triangle in the unrationalized. So 1 over rad 3, -1 over rad 3. So opposite, adjacent, that made this 2. So you can see the reference angle here is going to be actually at 30 degrees. But notice I drew it in the pre-first quadrant, so that's like a negative pi over 6, right? Had to think there, plus pi n. And you only have the one answer because when I add pi to it, it'll give me the other quadrant where tangent is negative. Okay? Okay, so now we're going to start solving within intervals. And this is something we did do last year. I do it several different ways. In class I did it, our traditional way with the fill out a table, n equals 0, n equals 1, blah, blah, blah. But I also do it just by mapping because we are going to be looking at solutions within an interval, usually like 0 to 2 pi. So just a little reminder that if you have a closed bracket, that's equivalent to a solid dot, so it includes the endpoint. If you have the round, it's equivalent to an open dot where the endpoint is not included. So you just want to pay attention to that when you're giving your solutions, okay? All right, let's get into this. So we have here cosecant squared x minus 4. I don't know why we did that, but we did. So what's going to happen is I'm going to first isolate my trig. And I don't want to do cosecant because we're not dealing with arc cosecant. So I'm going to turn this into a sine, which means this becomes 1/4. That's the reciprocal part is the ratio. And now I can take the square root of both sides. When you take the square root, there will be a plus or minus. So I've got now sine x equals plus or minus 1/2. Okay. Now, I personally just go here and then figure it out because I'm looking at all the places because we have both the plus and the minus. Well, let me just I'll go one step further down here. We know x equals inverse sine 1/2, and we're also trying to solve for x equals inverse sine -1/2. That basically covers, if we're going from 0 to 2 pi, this goes with a 30-degree reference angle all around. So it's going to happen here, it's going to happen here, it's going to happen here, and it's going to happen here. So it's going to happen at, so we're in radian mode, it's going to happen at pi over 6, at 5 pi over 6. Those are your two positive values. It's also for the negative, it's going to happen at 7 pi over 6, and at, oops, did I go too far? Pi over 6, 5 pi over 6, 7 pi over 6, I feel like, 11 pi over 6, there we go. That's the very last one. Those would be my 4 values. Now, if you're not sure and you actually want to work it out, it's more work, but you're more than welcome to do it. So what does this mean? This means, okay, if I do it, it just makes it so much more work to do it this way, but I will do it. So if I'm going to be really good about this, I would say then this is going to be a plus 2 pi n, and this one would be plus 2 pi n. But we're not going to be adding 2 pi because we only want within 2 pi. So that's kind of crazy. I know this answer is going to give me pi over 6. And the supplement, pi minus pi over 6. That's where we get the 5 pi over 6. And this answer down here, that's the negative 1/2, is giving me, I should draw my solution to negative pi over 6, and the supplement to that, which is pi minus a negative pi over 6, which is actually plus, and that's 7 pi over 6, and then you want to give the answer in the correct, just within 0 to 2 pi. To me, that's just so much more work and more confusing than just realizing where is sign 1/2 in the interval from 0 to 2 pi. But just, I know some people like to just follow one way to do things and stay with it. Okay, let's do this next one. This one, 5 cotangent x, and we're going from 0 to 720, which is a little bit annoying, but that's okay. But the nice thing is, notice it's in degrees. So first thing we want to do is isolate. So that's going to equal a negative 1, and of course I don't want to do it as a cotangent, so I'm going to do the tangent of, this should say theta, since that's in degrees, equals a negative 1. All right, so we're finding theta equals the inverse tan, negative 1 plus 180n. And so inverse tan, where is it negative 1? That's when you have a isosceles triangle, 45, 45, and it's negative, so it's going to be down here, and it's going to be up here. Now, this is what I do. I know this is going to be a little bit crazy, and I will do it the long way as well for you, but I don't do it the long way because that's just so much work. I just find it better to just kind of conceptualize what you're doing. So I draw my little grid. It is 0 to 720. That's twice around the circle. So there's once around the circle, and then twice around the circle. And I know that I'm looking for negative 1 is going to be down here at negative 45 degrees and at 135 degrees. So here's my 1, 2, 3, 4 answers. That's where they're going to come from. All right. That's really what I do, to be perfectly honest. I don't do this with our little tables. So what would that give me? So as I start going down the yellow brick road, my first would be 135, because we want it in that interval. Then, so that took care of that one. Then I keep going around the circle to go in order. The next one is here at 315. And I'm basically adding 180 each time. Then I add 180 to 315, and I'll get 495. And then I add, so that gave me this value. And then the last one, you add 180 to that, and we get 675. And those would be my 4 values. And I think I'm going to leave it at that, because, you know, to do it with the tables and principal values, since you're looking for a specific interval, I actually find this to be a lot easier. But let's do some more problems, because they are going to get more difficult. All right, so here we go with some full-on equations. So this first one, 0 to 2 pi, so we're in radian mode. I always want to kind of establish that before we get started. We have cosine squared x minus 2 cosine x minus 3 equals 0. Looks a lot like a quadratic. So first thing we're going to do is factor this puppy. So this is going to give me cosine x here, cosine x here. What times what is a negative 3 but adds up to a negative 2 would be minus 3 plus 1. So we're going to set each factor equal to 0. I was going to take a little shortcut there, but I won't do it. I will hold back. So we want to isolate our trig. and then isolate our trig. And in this case, hopefully you realize for this one here, cosine, remember this is 3/1. That represents adjacent over hypotenuse. That is not possible. You cannot have your adjacent longer than your hypotenuse, so that won't give us an answer. But over here, where is cosine? Well, let's actually write it out. X equals, so you have your plus or minus inverse cosine, -1 plus 2 pi n. But the reality is cosine is -1 only at 180 degrees. And we only want our answer from 0 to 2 pi, and there's only one place where that happens. So we don't have to really do a big box and figure it out. You're only going to have the one solution. All right. I'm going to erase this part right here because it's going to get in my way for the next problem. All right, let's start this next problem. Secant squared minus tangent theta minus 1. Now the problem here is you have two different trig, which is why we did all those identities before. So you are going to have to transform one of them, and I can't do anything with tangent, so we're going to pick on secant squared and replace it with its Pythagorean identity. And then we have minus tangent theta minus 1 equals 0. So very nicely, my 1's will cancel. And so I have tangent squared minus tangent equals 0. And I can factor out the tangent. So I have minus 1 equals 0. Also, I should have mentioned this before I even started. Yay, we're in degrees. Degrees are just so much easier. So this is going to be tangent theta equals 0. This one will be tangent theta minus 1 equals 0, so tangent theta equals 1. Sorry, I did take a little shortcut. I think you can handle that one. All right, so let's kind of look at our definition. So we're looking for tangent theta, where inverse tan 0 plus 180n. And over here, I'm going to have theta equals the inverse tan of 1 plus 180n. All right, and we want to evaluate this. So tangent is 0. Remember, that's y over x. So your y value is 0 at 0 and 180. And we want our principal value, we're going to choose 0 degrees plus every 180n. Tangent is 1, positive 1 in the first quadrant at 45 degrees plus 180n. Now again, there's two ways to do this. I'm going to kind of map out here because we're finding our solutions from 0 to 720. Remember, that's once around and then twice around. So my answers are going to come from here. You're going to have a lot of answers on this one, here and here. And also for the other one, 45 degrees, all of these, because you have to then go through 45. But what I'm going to do, I am still going to do the table. I don't usually do a table on these ones. I usually map it out because it is a specific interval. But I've been working with the table up to now, and I know people kind of like that, so we'll just stick with it. All right, so when n is 0, our two principal values were 0 degrees and 45 degrees. And when n is 1, we're basically adding 180. So this will be 180. And then I'm going to get to 360. I usually just work across one row. So after 360, we add 180, we get 540. We're still within our 720. And if I add 180 to 540, voila, 720. And since that has a closed bracket, we are going to include it. Now we come down to the 45 degree and we just keep adding 180. So that's going to give me 225. Add 180 to that gives you 405. And this is why it's nice to have those big calculators, because you wouldn't be allowed like a scientific calculator for this. but just for adding and subtracting, it's kind of nice to have something to make it a little easier. So 405 plus 180 is going to be 585. And if I add another 180 to that, I believe that's going to put me outside my range. Yeah, that puts me at 765, which is too far. So notice I have here 1, 2, 3, 4, 5, 6, 7, 8, 9 answers. And if I look at all my little dots, 1, 2, 3, 4, 5, 6, 7, 8, I see the one I missed, 9 answers. So then we would just list these out, and it's nice if you can list them in the order you see them. So I'm going to write it small: 0, 45, 180, 225, 360, 405. I feel like I'm writing the disclaimer on some medical thing. Make it really tiny so no one actually reads it. Okay, that would be your solution. Okay? All right, last one. Oh my gosh, I remember this one now. Oh, you're not gonna like this one. This one's gonna be ugly, but it's okay. So if you were in class, well, let's start it off. Okay, same thing, 5 cosine squared plus 2 sine. I have 2 different trig. I only need 1 trig. Can't do anything with sine, so we're gonna pick on cosine. So this is gonna be 5 times 1 minus sine squared x plus 2 sine x minus 4, because I want to set it all equal to 0. So I distribute this, 5 minus 5 sine squared x plus 2 sine x minus 4 equals 0. Combine our like terms. So negative 5 sine squared plus 2 sine x. 5 minus 4 is a positive 1. So I'm going to have to potentially factor this, maybe. And I don't like negative lead coefficients. So if it's okay with you, I'm going to multiply everything by negative 1. And so I have this. Now, if you try and factor that, then you are superhuman because it's not factorable, which what happens when you have a quadratic that's not factorable is you have to do the quadratic formula. So this was what I was about to say, is in class I gave everyone the quad formula on their calculator because I don't ever do the quad formula. That's silly. So when you do the quad formula on this, I'm going to have to do it again. My A is 5, B is a negative 2, C is a negative 1. All right, we get 2 answers. We get, because remember this is sine x, not just x. So sine x equals 0.690, and sine is also going to equal negative 0.290. All right. Okay, so I kind of skipped the hard part. I don't do quadratic formula. It's like you're in pre-calc now. You shouldn't have to do things like rationalize denominators and plug into the quadratic formula. So we just use the formula, the program. Okay, so what I'm going to have to do is do my inverse sine routine. So the inverse sine of 0.69, and again I am in radians. So this would be plus 2 pi n, and then you also are going to have to then find the supplement, remember? So we're just going to write this out. So there's one of your solutions. The other solution over here, and again we haven't plugged it into the calculator yet, but we will. Be patient. This problem is a bit of a pain. Plus 2 pi n, and the supplement to that. Okay, negative 0.29 plus 2 pi n. The nice thing is we just are finding a solution from 0 to 2 pi, so that's not going to be too icky. Okay, and remember 2 pi is equivalent, so we're really going from like 0 to 6.28 because that's the equivalent of 2 pi. Alrighty, so let's start to get our values here. So inverse sine of 0.69, get to my calculator, it's giving me issues. Come on, stop. There we go. Okay, second sine, was it negative? No, just 0.69 is 0.76. So x equals 0.76 plus 2 pi n, and pi minus that. So pi minus 0.76 gives me 2.38. 1, sorry, 2.382 plus 2 pi, I guess there was a 1 after this one, plus 2 pi n. All right, and notice if I'm only going from 0 to 2 pi, as soon as I add the 2 pi n, that's going to take me outside my range. Now on this other side, whoa, what did I just hit? I'm going to have inverse sine negative, so second sine negative 0.29. That gives me, over here, x equals negative 0.294. It's kind of interesting how it came out almost the same. And then pi minus that is going to be second pi minus second answer, 3.436 plus 2 pi n. So I know that this is going to be an answer. I know that this is going to be an answer. I know that this is going to be an answer. The only one that I have to really add the 2 pi to is the negative, because that's, we want from 0 to 2 pi. So I'm just going to go 2 pi on my calculator minus 0.294. So this is going to give me, so basically I'm letting n equal 1, and I get 5.989. And that will be my fourth answer. And then just putting those in order, starting with 0.761, then 2.382, then 3.436, and lastly 5.989. That's all within the 0 to 2 pi. So I'm less than the 6.28. If I keep adding another 2 pi, I'm going to be outside my range. Whew, that was intense. I know. Okay, well, I hope it made sense. And just don't worry, there's not going to be too many quadratics, but if one does come up, you are going to be allowed to use a quad program, or if you have a TI Inspire, you have the program already built in. Okay?